Okay, so now we're going to start looking for local maxes and local mins, and we'll use the derivative to help us. So first derivative test, 3 possibilities if you have a critical number. So critical number, remember, it means that f prime is either 0 there or f prime does not exist, but c is still in the domain of f. So 3 possibilities. So let's say we have like an f prime, and then it's positive and then negative afterwards. And here's our c here. So we have a critical number, and my function is with a positive derivative, so it's increasing. So visually, you have increasing, 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 and then maybe like, well, often you'll have like the top of the hill here, and then you'll have decreasing, 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 right? So in this case, we have a local max. Okay, so this is the first of the 3 possibilities where you have a positive derivative before and a negative derivative after a critical number. Remember here you have f prime of c is 0 or d and e. So in this case we have a local max. You can also have a local min. Okay, that would look like a minus and plus. And then you're decreasing before the c and then increasing after, like so. Local min, or minimum if you prefer. Now you can also have a situation where neither nor. You have a situation where you have your c here, and f prime is increasing before and increasing afterwards. This does occur, so you could have something that going increasing, 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 increasing momentarily flat, and then increasing again afterwards. So this is neither. It doesn't look flat to me. It should be flat here, flat, 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 and then increasing again. So this is neither max nor min. It's not an R. Okay, so this is possible. So I went with plus plus here, but you can imagine also the case where you have minus minus. So all of these things happen, and we have to be aware of them. So we call this the first derivative test. So it says that if you have a critical number, then one of these 3 things is going to happen. You're either going to have a local max there, a local min, or maybe you'll have, or maybe you'll have nothing. Okay, let's do an example here. To illuminate. So, pause and copy. So I'm going to take a derivative, and I'm going to find out when that derivative is 0, and then I'll find out when it's positive and negative, and then I'll be able to talk about local maxes and mins. F prime of x is, I get 2 cos x times minus sine x for my chain rule. Then I get 2 cos x. As a good calculus student, I immediately, without hesitation, factor out the common factor. And I get that, don't I? Don't I? Yeah. Oh, uh-oh. Ho, ho, ho. Too much talking, not enough thinking. Is that better? Yeah, that's better. Okay. So I had a bobo there. So I want to find the critical numbers. So I set this equal to 0. I should notice that f prime always exists because sine and cos both always exist. There's no denominator issue here. So I'm just going to look at f prime equals 0, and I get cos x equals 0, or looks like sine x equals -1, coming from this bracket. So solving these two equations between 0 and 2 pi, from my memorized unit circle, what do I get? Cos x is 0. Here I get pi over 2 and 3 pi over 2. And here I get cos x is -1. That would be just 3 pi over 2. It's the only solution I have between 0 and 2 pi. Cos x is 0, yeah. Okay, so these are my solutions here. So I do my number line. My number line is restricted now. It's only 0 to 2 pi. 0 to 2 pi. And then I get, what do I get? That would be about pi over 2 here. And roughly 3 pi over 2 down here. Now I want to figure out the sign, plus or minus, of f prime here. Here's my f prime here, so I should write that in a convenient form. F prime of x is 2 cos x. Maybe I should clean this up even more. It's going to make my life easier if I just put a little bit of effort in here and make this a bit cleaner. So I'm going to go -2 cos x. And then the bracket, sine x plus 1. So doing test points. Doing test points, I can do pi over 4 here. Pi over 4 would be here. Pi is about there. And what should I do over here? This is a bit awkward. You can do I do 7 pi over 4. So I'm really testing my unit circle here. So that's a 7 down there, 7. Okay. So I'm going to do these green test points. I'm going to plug them in here to see what I get. So f prime of pi over 4 is, I get -2. The cosine is positive. The sine will also be positive. So I get less than 0 here. F prime of pi is going to be -2. Cosine is negative. The sine is 0, so this is plus for this bracket here. So that's bigger than 0. Then f prime of 7 pi over 4. Cosine is positive. This bracket will also be positive since how do I know that? Sine x is going to be less than 1. sorry, sine x is, say, bigger than -1. Like this bracket's just is not going to be negative. It could be 0, but it's never going to be negative. But in this case, it's going to be positive. So less than 0. Okay, using my test points, what do I get? I got a minus here. I got a plus here. And I got a minus here. So my function is doing something like this. And it's doing something like this there. So local min at x equals pi over 2. And I should calculate the corresponding y value. So I'm going to have to calculate f of pi over 2. I'll do that shortly. I just want to finish my statement here. Local min at x is equal to 3 pi over 2. Nope, sorry. Mistake there. Local max. Local max here. 3 pi over 2. And I should calculate the value of f at 3 pi over 2. And I've forgotten what f is. So I'm going to have to take a sneak peek at what f is. What is f again? Cos squared minus 2 sine x. I'll write that down for myself over here. Cos squared minus 2 sine x. So cos squared minus 2 sine x. So for this guy here, what do I get? I get 0 squared minus 2, which is minus 2. And 3 pi over 2, the cosine is again 0, but then I get plus 2 here. All right, so I found my local max and my local min subject to these restrictions.